Hey, look, it's nighttime now. Kids went to bed, and now we can actually get something done. We can talk about some good stuff. Now we can talk about the numerous statements of the second law. Okay, and there are numerous statements of the second law. We're going to talk about an engineering, a thermodynamic statement of the second law. But you know, I use the second law. I love the second law. Uh, it says nothing is perfect. That's what the second law says. It just defines nothing is perfect. It can say things only get worse from when they start out. That's one that way you can say the second law in layman's terms is, or lay people terms, is things only get worse. I had a student who was talking to me whose cousin was going to seminary, and so for those of you who aren't maybe familiar, seminary is a school you go to if you want to become a person of faith and in the I guess maybe I don't know everything, but it's in the Protestant and Catholic churches that you would do those kind of things. And they talked about the second law of thermodynamics with regard to sin when it goes into and also with evolution. Now I know some seminaries don't talk about evolution, but some do. So there was a lot of interesting talk about that. They want to talk to me about the thermo version of it versus the theological version, the theological version of it. In economics, there's an idea of thermoeconomics which talks about the second law of thermodynamics. Okay, I tend to do it with the second law of teaching. I gave a talk a few years ago called the second law of teaching, where the best laid plans. You're never going to get to the very end. So I have that second law here. The heat death of the universe is all about the second law. If you want to spend some time thinking about the heat death of the universe, which will eventually happen when entropy is something which we're going to talk about, all evens out in the universe. But that's where we kind of get to this idea of entropy. And entropy is our one remaining property that we have not talked about. It's that last column that's in our textbooks and our appendices. And we will talk about entropy. Not until chapter 6, though. But I want to introduce you to entropy right now. It connects all the theories and the ideas together with us, and it helps us tell the direction of processes, entropy. And so what I'm going to seed you with right now in this lecture segment is what entropy is. Okay, because the second law of thermodynamics, some people call it time's arrow. Okay, there's a direction of this, and I mean that reminds me of the greatest movie trilogy of all time, which is Back to the Future. And if you haven't watched Back to the Future, spend some time, watch Back to the Future. It's a great show. Hello? Cat. A cat. Now I have a cat coming in the door. I thought it was a kid waking up. Anyway, entropy can be considered like glitter. I think of it like glitter or sand or whatever you want to say. And what we do when we start a process, we put all this glitter or all this sand in our hands. Okay, and we're trying to make a process, and as we go from state 1 to state 2, some of that sand or some of that glitter is going to fall out of our hands. We can't perfectly hold it all. Something's going to happen. A gust of wind's going to come by, blow it out to get to our state 2. And there's no way that we can go from state 2 back to state 1 and all that sand or all that glitter magically comes out from around and goes back into our hands. That just doesn't happen. What's going to happen is we go from state 2 to state 1. What's going to happen? More glitter is going to come out. More sand is going to fall out. Okay? And that creation, that deposition of entropy, of sand on the world tells us the direction of processes, tells us what's going on. It is the idea of the second law that we need to grasp on to. So as we go from state 1 to state 2, we leave a mark on the surroundings, okay? And we're calling that mark the generation of entropy, okay? And I'm going to list it as that sand or that glitter falling out of our hands. No matter where we go, from state 1 to state 2 or from state 2 to state 1, always goes out. It's not conserved. It doesn't conserve. Okay, that's the idea of the second law that we want to talk about. So we're going to circle back around to this in starting chapter 6. But I want us to think about a couple of things here. I'm just going to talk here, and maybe I should make it full screen here. But if energy form A is easier to convert to energy form B, that B is the B is higher than A. Let me say it again. If energy form A is easier to convert to energy form B than B is to A is ranked higher. I want to make sure I said that because I think I messed up the first time I said that here. I'm trying to read it off there and look up here on the screen. If energy form A is easier to convert to energy form B than B is to A, then A is ranked higher. Our highest forms of energy can be turned into other different things. Our lowest forms of energy are kind of just there. They're not very useful. Okay, we like things to be in the higher forms. We try to get as much use out of them as possible until they go to the lower states. We try to take as much as we can. Okay, so starting a fire. Okay, when we start a fire, that's a really high form of energy. If we just let it burn, it's going to go right into that energy is going to go right into the atmosphere and then just dissipate. What we want to do is take that fire and use it in a process. Use it in a process to heat something up, heat up water, that then we can use that hot water for something. That's what we want to do. We want to take as many steps as we can from that fire to when it gets dissipated into the atmosphere. That's the main goal here. We do it every day. When we're moving around, we're dissipating kinetic energy, and that just goes into the environment. And so we want to grasp hold of that kinetic energy. I do that with my watch. My watch is a Seiko kinetic watch. As I'm going back and forth, it's constantly using that energy to keep that watch battery going. Okay, so those are some ideas that I want to leave you with in this short segment about entropy and about levels of energy and about how the second law is going to work with us. And we'll continue on in the next segment talking to us regaining, or what do I want to say, reimagining, revisiting, that's the word, revisiting something from our past here in thermal.